Assalamualaikum and good morning to Puan Siti Noor. My name is Muhammad Dafki Naim bin Muhammad Noor. My number matric is 15 BMA 19F 1004. Today I and my friend want to present about the implicit and first derivative function.
My name is Aiman bin Muhammad Rahman, number matric 15 BMA 19F 1021. So today I would like to present about first, this is for calculus for engineering technology. So this is me and my friend Dasuki Naim. So first principle and derivative. In first principle and derivative, we must use this formula to solve the equation. So if we have a question, this is the solution. So this is the formula we put under the question to solve, to easy the solve of question. So the question we must take out from to for to differentiate the x. So we differentiate x is x plus h. So we change the x to x plus h into the x tangent. So after that we use the equation, then we put the this equation into the formula, and this for fx, we take this formula to this. So we can get we expand the 3x over 3 plus h over 3 plus 3x over 2h plus 3xh over 2. Then we close the bracket and we minus 2 minus 3x over 3 plus 2 divided by h. So we got the same equation. This is 3x over 3 and 3x over 3. So 2 and 2. So we simplify the equation into 3h over 3 plus 9x 2h plus 9xh over 2 divided by h. So we can get this equation. Then we change the h into 0 as we see at limb here. So we can get 3 times 0 over 2 plus 9x2 plus 9x times 0. So we can guess the final answer, that is 9x over 2. So we go through the my friend Naim.
Hello, Assalamualaikum and good morning. Now my turn to present. Now my turn to present about the differentiation of implicit function. Okay, for the example, if a function, if in our case, one variable can be written in a term of the other, for example, y in term of x or x in term of y, these are explicit function. For example, in this example, f x y equal y power of 4 plus 2x square y square plus 6x square plus 7. For the implicit function, you must remember d, if differentiate s, d per ds s equal 1. And for if you implicit y, you must remember, you must put dy ds after you differentiate. For the example is 1 and dy dx because you are differentiate y. Okay, next we move to the exercise number 3. Given the implicit function 3x square minus 2y square plus 4xy plus 13 might equal 0. Find the gradient of the function at point -1, 2. Hence, find the equation of normal to the curve at point -1, 2. In this question, you can see, you must see which one can be differentiated by s and which one cannot differentiate. For this question, as you can see, for sy, you cannot be solved because if you want to solve for sy, you must use another method. That method we call a product rule. So the first step you must need to do is for xy. This is a formula for product rule. U dv per ds and v d plus v du per ds. That is a formula for product rule, and you differentiate u equal 4x and du equal 4 after you differentiate, and v equal y and dv equal dy per ds. So we solve the problem 4x times dy per dx plus y times 4, and we can get the answer for product rule 4s dy per dx plus 4y. This is for product rule, and we move for the equation at the question like that. 3x square minus 2y square plus 4xy plus 13 equals 0. Okay, for the first step, you must differentiate d per ds 3x square minus d per ds 2y square plus d per ds 4xy plus d per ds bracket 13 equal 0. And then after you differentiate 3x square, you can get 6x minus the answer of differentiate 2y square, you can get 4y dy per ds. Why this one answer have dy per ds? That's why I said if has y, you must put dy per ds at the back plus 4x dy per ds plus 4y. This is a answer for product rule that we have done for 4xy. So we just put down the answer of product rule in this equation, and we solve the problem. We rearrange the equation like that. The if have dy ds, we put at the left hand side. As you can see in this example, negative 4y dy per ds. We take this one, put here to the left hand side, and plus 4x dy per ds. We take this one, that's a product rule, right? Okay, 4x dy per ds. So we rearrange the equation dy ds at the left hand side, and we rearrange the equation negative cs at the right hand side. As you can see, cs become to negative cs, and 4y we take to the right hand side, we become negative 4y. That's a new equation. Okay, now we move for the solution. We simplify the equation. Dy per ds, open bracket, negative 4y plus 4x, close bracket, equal negative 6x minus 4y. Okay, so the next step is you must differentiate. You rearrange the differentiation. Dy per ds equal, open bracket, negative 6x minus 4y, close bracket, per, open bracket, negative 4y plus 4s, and close bracket. Now you simplify the equation to be simple. You can get 2 times negative 3x negative 2y per 2x minus 2y. So you have to simplify the equation. Okay, these two you can cut. Now you have 3x minus negative 3x minus 2y per 2x minus 2y, and you take down the differentiate. Negative 3x minus 2y per 2x negative 2y. So we have done the equation. Now, based on the equation, at a point negative 1 for s and 2 for y. So we want to find a gradient. M is a negative 3. This is for s. We put the negative 1 because negative 1 is s, and negative 2 and 2 is y. So this one is for y. As you can see here, we put 2. So that means the equation become negative 3 times negative 1 minus 2 times 2, and per 2 times negative 1 minus 2 times 2. Same with this equation, y and s. You just take negative 1 for s and 2 for y. Now, after you solve the equation, you can get negative 1 per negative 6. Now you be simplify, you cut the negative, and you can get m equal 1 per 6. That's for gradient. Now, based on the question, we want to find a normal to a curve. The formula is y minus y1 equal negative 1 per m, open bracket, x minus 1, and close bracket. So for y, we write again y minus 2. 2 is for y1. We replace with 2. equal negative 1 per 1 m. M is for gradient. We just take this one answer and we put as a m is 1 per 6 and open bracket x minus bracket negative 1 and close bracket. Negative 1 is for the x. And then we can get y minus 2 equal negative, and we solve this equation, we can get negative 6x minus 6. We can get this answer, and then we solve negative 2, we replace to the right hand side. It become negative become positive, so positive 2. So negative 6x minus 6 plus 2. We have done the equation and we solve these two. Negative positive is become negative, so negative 4. So the answer for the normal to a curve is y equal negative 6x minus 4. That's for final answer for normal to a curve, and that's final answer for gradient. Okay, that's all from me. Thank you.
Thank you.